Hello children, in this video we'll learn how to determine the number of zeros a quadratic polynomial will be having by taking the help of discriminant. So before knowing what is discriminant, we need to know what is the general form of a quadratic polynomial. That we already know, that is px is equal to ax square plus bx plus c. What is a? That is the coefficient of x square. What is b? That is the coefficient of x, and what is c? That is the constant term. Now, what is discriminant? Discriminant is the value that we get on calculating b square minus 4ac. b is the coefficient of x, a is the coefficient of x square, and c is the constant term. This b square minus 4ac, whatever numeric value we are getting, that value is called discriminant. D stands for discriminant. So when this value, whatever polynomial you are having, quadratic polynomial, you will calculate the value of d, that is b square minus 4ac. If d is coming greater than 0, if d is greater than 0, then the given polynomial will be having two real zeros. If d is equal to 0, if the value of b square minus 4ac is equal to 0, then it will be having one real 0, and that will be repeated. That is the case of 2 equal 0 actually. Sometimes you are getting alpha is equal to 2, beta is equal to 2, alpha is equal to 3, beta is equal to 3. When you are getting 2 equal zeros, that means the same number is getting repeated. That is the case of one real 0 and the 0 is getting repeated. Now the third case, if d is less than 0, then no real zeros will exist. No real 0. Now what is no real 0? You must be thinking, if there is a polynomial, quadratic polynomial, it must be having 0. Then how it is no 0 we are discussing? No real 0 means it will be having two zeros. Those are imaginary but not real numbers. Imaginary means that is involving iota. You will learn about that in the higher classes. For the timing only we'll discuss about the real zero. So now let's recapitulate the graphical interpretation of these conditions which we have already discussed earlier. D greater than 0 is saying two real 0. That means whenever discriminant is coming greater than 0, the polynomial graph will be like something like this. It will cut the x-axis at 2 points here or here or like this. Somewhere it will cut the x-axis at 2 points. But when the discriminant is equal to 0, the graph will be like, it will touch the x-axis at only 1 point. Like this, or like this, somewhere, but it will touch the x-axis exactly at 1 point. But when it is less than 0, it will not touch the x-axis at all. So it will be like this, somewhere like this, but it will not touch the x-axis. Okay, so when discriminant value, that is b square minus 4ac, is greater than 0, it will be having two real 0. That means the graph will cut the x-axis at 2 points. When d is equal to 0, one real 0 which is getting repeated. That means the graph of that particular polynomial will touch the x-axis at exactly 1 point. When d is less than 0, no real 0 is existing. That means it will be having some imaginary zeros and it will not touch the x-axis at any point. That is what we are saying, 0 zeros exist. Okay, now let's take some example to see how the value are coming differently. Like in some of the case you will get d greater than 0. In some case you will get d is equal to 0. In some case you will get d less than 0. So let's take some example. I am taking example 1 here. With a condition, we'll try to take d greater than 0. Let's see. Let's take the polynomial first. Suppose px is equal to 5x square plus 12x plus 4. Now, in this particular polynomial, what is a? A is equal to 5. What is b? B is equal to 12. What is c? C is equal to 4. So, discriminant is what? D is equal to b square minus 4ac. So let's substitute the value. What is b? 12. So let's take 12 square minus 4 into a into c. 12 into 12, 144. Then 4 into 5, 20. 20 into 4 is equal to 80. Let's subtract 4. 14 minus 8 is equal to how much? 6. So we are getting D is equal to 64. So it is greater than 0, equal to 0 or less than 0. We can clearly see 64 is greater than 0. So we are confirmed now that this particular polynomial 5x square plus 12x plus 4 is going to have two real zeros. Two real zeros. So let's verify it whether our answer is actually correct or not. Okay. So how we'll verify? Let's try to find out the zeros. 5x square plus 12x plus 4. 5 into 4 is 20. This is the rough work. 5 into 4 is equal to 20 and 12 is given. That means on multiplication the number should give 20 and on addition the number should be 12. So what are the numbers? Obviously it will be 10 and 2. So 5x square plus 10x plus 2x plus 4. This is 5x, let's take out as common, it will be x plus 2, then again 2, take as common, again you will get here x plus 2. So we are getting eventually 5x plus 2 into x plus 2. Let's equate to 0, so in order to get the zeros, implies that sign here. So here 5x plus 2 is equal to 0, this implies x is equal to minus 2 by 5. Similarly, x is equal to, in this case, it will be minus 2. So, what are the 0 you got? Minus 2 by 5 and minus 2. And here, by using the discriminant, what conclusion we have got? That two real zeros are existing. And verification also we found that yes, two zeros are there. So, this is the first case. Let's go for the second example. Let's take px is equal to x square plus 4x plus 4. Here on multiplication you should get 4 and on addition you should get also 4. So what can be the numbers? Obviously it will be 2 and 2. So x square plus 4x plus 4, let's equate to 0. This implies x square plus 2x plus 2x plus 4 is equal to 0. This implies, let's take x as common, so it will be x plus 2. Again let's take here 2 as common, so again it will be x plus 2 is equal to 0. So x plus 2 into x plus 2 is equal to 0. Here x plus 2 equal to 0 and again x plus 2 is equal to 0. So this one x is equal to minus 2, again you are getting minus 2. Basically it is the same number which is getting repeated, where discriminant is equal to 0 when we are getting, we are saying that we will get one real 0 which will get repeated. So first we have calculated the 0 here. So now let's check whether we are getting the discriminant as 0 or not. So in this case, what is A? A is equal to 1. What is B? B is equal to 4. What is C? C is also equal to 4. Okay, so let's calculate the discriminant. D is equal to B square minus 4AC. We are checking here whether we are getting it 0 or not. Okay, so B square means 4 square minus 4 into 1 into C. That is 4. 4 square is 16. 4 into 1, 4. 4 into 4, 16. 16 minus 16 is equal to 0. So this one is a discriminant is equal to 0 is saying that it will be having only one real 0 which will be getting repeated. And in the first part only we have calculated the 0 and we have seen that x is equal to minus 2 here which is getting repeated. Now let's go for the third case. Example number 3. Let's take px is equal to 4x square plus x plus 5. 4x square plus x plus 5. What is A here? 4. What is B here? 1. What is C here? 5. Let's find out the discriminant. Is equal to B square minus 4AC. B is 1, so it is 1 square minus 4 into A is equal to 4 into C is equal to 5. So 1 square is 1, then 4 4s are 16, 16 5s are 80. 1 minus 80 is equal to minus 79. Here the discriminant value is coming less than 0. So this particular polynomial will not be having any real 0. So here no real zeros exists. So this particular graph if we will plot, then it will not touch the x-axis at any point. So when d is greater than 0, it will be having 2 real 0. When d is equal to 0, it will be having exactly 1 real 0 which is getting repeated. And when d is less than 0, it is not having any real 0. I hope it's clear now. Thank you everyone.